it's Mario and Luigi.
I'm gonna win.
And that's probably
Wario?
Okay.
I don't know.
So here we are. We're going to talk about electromagnetic spectrum, and we're going to be cruising down Rainbow Road as we talk about electromagnetic spectrum, because electromagnetic spectrum, my mustache is in the way, is dealing with the colors of the rainbow.
Like Rainbow Road.
Like Rainbow Road.
And reading Rainbow?
Mm-hmm. So first we're going to go with the visible spectrum. Now that's the part, because it's visible, we can see.
Oh, okay. So like every color.
Yes.
Perfect.
Like Roy G. Biv.
Oh, our buddy.
Yeah. Okay, like you learned in kindergarten, they sing about it on Sesame Street. Roy G. Biv, red,
Wonderful.
orange, yellow, green, blue, indigo, violet.
Love it. Yep.
Okay, and it's a continuous spectrum, and all the colors tend to blend together, so you can see down there at the bottom how they go through the shades.
Okay. So green kind of blends into blue blends into indigo, whatever color that is.
Yeah.
Okay, gotcha.
Yeah.
Yep.
Okay, now they all have different wavelengths. Okay, and so the shortest of the wavelengths is the violet side of the spectrum, and the longest is the red side of the spectrum.
Okay, kind of makes sense. Mm-hmm. So the different sized wavelength, the different color we see.
Exactly, yes.
Perfect.
Yes. And then, of course, there's different frequencies. Now, frequencies, of course, is how often it happens.
Okay.
Frequent.
Okay, so okay. Is that related to wavelength at all?
A little bit. We're going to get there. Don't get ahead of me.
Oh, I will not.
Okay, so if you've highest frequency, though, is going to be that violet.
The violet.
So, and then lowest frequency is going to be the red.
Cool.
Okay, so you can probably already see a little bit of relationship. Short and high is violet.
Ooh,
long and low, red.
I love it. Oh, you're good. Okay.
Now then there's the rest of the spectrum, the stuff that we can't see.
Okay, so it goes all the way from gamma, which looks like they're super short, all the way out to like radio waves, which are very, very long.
Right. Now those gamma rays we talked about in, of course, the nuke section of this unit.
Yes, they are gamma radiation.
Exactly. Yeah. Okay, so they can, penetrate the furthest, as we talked about, and that's because they are a clear wave that has a lot shorter of a
wavelength.
Correct. Thanks.
High frequency.
High frequency is short wavelength.
Gotcha.
Yes. So, but some other examples that you might know: X-rays, radio waves. Okay, the TV. The TV.
Microwaves.
The microwaves.
Oh, the microwaves.
So, and they're all on there too. Those are the ones that you can't see.
Gotcha.
So that's kind of why they talk about those people with pacemakers. They shouldn't stand too close to microwaves because they could interfere with the ticking. Okay. Yep.
Okay.
All right. Moving on. Okay. And then infrared, which is
below red, right?
Yes.
Infrared, below red.
Infrared, below red. Got it.
Got
Okay.
it.
Now, there's a calculation for this, but I had to throw up the calculator
To calculate.
And plus, we wanted to show you a few special things on how to put this into your calculator.
We are special.
So, for example, the light equation itself is C equals lambda. That's a crazy little V. Lambda, Greek letter. In the science world, we really like those Greek letters.
Apparently, and just letters in general. There's no numbers there.
No numbers. However, C stands for the speed of light.
Oh, okay.
So the speed of light, that's 3.0 times 10 to the 8th meters per second.
So that's a constant.
That is a constant.
It's always that.
Exactly. The speed of light never changes. Speed of light is the speed of light.
Well, fun fact.
Okay. Then we have the wavelength. Okay.
That's our gamma.
The lambda. And then we have the frequency, which is V. Now they have an inverse relationship. Do you know what inverse means?
I believe they go in opposite directions, correct?
Right. One goes up, the other goes down.
Perfect. Okay, yeah, I know that. Yep.
So we're going to try a little light equation example, okay? So the laser in a CD player uses to read it, obviously.
I don't understand what a CD player is.
I know.
Is that like an MP3
Old
player?
School. It is a little
bit.
Okay. So it plays music. Okay. Uses light with a wavelength of 7.8 times 10 to the negative 7th meters.
That's a weird number.
It is. But what is the frequency? Okay.
I don't know.
That's a great question, but we're going to figure that out. Well, we use our equation, C equals lambda V.
C equals lambda V.
Okay. C being the constant, which was
3.0 times 10 to the 8th meters per second.
Right. Speed of light.
Speed of light, sorry.
Lambda, we do not know.
That is what No,
I'm sorry.
We do know lambda.
We know lambda. They gave us the wavelength. I apologize. It's this guy right here. Okay? And then they're asking us to find V.
Okay. All right? Doesn't seem too bad.
No.
We can handle it.
So if I input it into where it stands for the variables, okay, 3.0 obviously there.
Yeah.
7.8 times 10 to the negative 7 there, and then V is our unknown.
Perfect.
Which is super easy. We're just going to solve for V. The only tricky part now is when you put it in your calculator.
Yeah, those numbers have multiplication signs in. Oh, that's a little confusing.
Exactly.
Yeah.
So how you're going to enter this into your calculator is you're going to press 7.
Oh, you're doing it right there.
8
Yep.
0.
Got that.
I'm going to hit the second button up here in the top left-hand corner.
Okay, dokie.
Press that, and then I'm going to press this comma button. And then I'm not going to do anything with this times or the 10. I'm simply going to press -7 and hit enter.
Okay, so in my calculator, it's going to look like 7.80
E minus 7.
E minus 7. Okay.
Okay? Yeah, so if you ever see in your calculator times 10 or times 10, you did it wrong.
Okay.
Okay?
You're wrong.
The little E that looks like, you're not going to see that, but maybe you will. That little E would represent the times 10 part. Okay? From here, we're just going to solve. So we're going to take 3.0 times 10 to the 8.
Okay.
And we're going to divide it by the wavelength.
There it is.
Okay?
Oh.
Divided by the wavelength.
Oh, love it.
Okay, it's a little slow coming in here. And we would get an answer of
Whoa, that's a big number.
3.85 times 10 to the 14th seconds. So it reads it very, very quickly, if you will.
Yes.
Okay. So now our meters, because we're here, this would cancel because we have one on top, this would cancel with one on bottom, and we're left with seconds.
So frequency, that is how many waves occur in a second?
Exactly.
Okay, so there's a lot of waves in a second.
Exactly.
Gotcha.
Okay? And that's about all we got because, of course, we got to get back to driving around on these go-karts.
Yes, these Mario Karts, if
Mario
you will.
Karts. Okay. We'll see you in class.
Bye.